High temperature solid particle erosion characteristics and damage mechanism of aluminum, cobalt, chromium, ferrite, nickel, and silicon high entropy alloy coating prepared by laser cladding. The solid particle erosion affects on aluminum, cobalt, chromium, ferrous, nickel, silicon high entropy alloy coatings prepared by laser cladding under the different erosion conditions was investigated. Furthermore, the transformation of the microstructure and properties of the prepared high entropy alloys under high temperature conditions and the effect of the oxidation on erosion behavior was analyzed. The results show the harshness aluminum 1.0% with 711 HV present typical Ritzler erosion characteristics as the fracture toughness deteriorates with increasing aluminum content. When the erosion temperature reaches 700 degrees Celsius, the erosion rate decreases due to the precipitation enhancements and oxidation affecting the erosion behavior. The erosion wear accounting for the approximate 8% of the abrasion failure is a common failure mechanism for engineering material, among which high temperature erosion results in a more serious loss of material and a complicated form for the failure. The primary factors responsible for the failure of metallic materials in the long-term storage in high temperature and erosion environment involve the reduction of the metal strength, harshness, the impact of solid particles with the high speed, high temperature oxidation. Thus, it has been one of the key topics in the field of material and science and engineering to understanding the damage patterns caused by these factors to metallic materials as well as select and develop the new high temperature erosion resistant materials for engineering equipment. The concept of the high entropy alloys was proposed by Year in 2004, which was a brand new direction for research and of the new materials. The unique thermodynamics, high entropy effects, crystal structure, lattice distortion effects, kinetic, sluice diffusion effects, and performance cocktail effects provide high entropy alloy with outstanding properties such as the high harshness, high wear resistance, high thermal stability, high oxidation resistance, which endows them with the potential for high temperature erosion resistance and dimensional potential and academic research values. Laser cladding is an efficient and environmentally friendly coating preparation technology with the advance of achieving precise control of engineering and quality, small heat affected zone, low distortion rate, and metallurgical bonding with the substrates. Besides the fast heating and cooling rate, the cooling characteristics of laser cladding can inhibit the nucleation of the intermetallic compounds during the solidification of high entropy alloy, refine the grains, and further improve the properties of high entropy alloys, which has become a research hotspot for the preparation of high entropy alloys. At present, there are a few reports on the high temperature erosion resistance of high entropy alloys, and the mechanism of high temperature erosion resistance of high entropy alloys needs to be further investigated. Both of the current studies on high-entropy alloy system are designed based on the cobalt, chromium, ferrous nickel system. However, cobalt, chromium, ferrous nickel high-entropy alloy with the simple FCC phase structure exhibit too low harshness to satisfy the requirement for the application in high temperature erosion environment. First, additional primary elements need to be added for strengthening. Several reports have proposed that the aluminum element with a large atomic radius effectively enhance the solid solution strengthening effects of the high entropy alloy system. In addition, non-metallic element silicon is effective in improving the fine-grained strengthening effect. And addition of silicon elements in the conventional alloys promotes the growth of the oxide film to laminar morphology, which is effective in reducing the amount of erosion loss due to the oxide film pooling in high temperature erosion environment. In this present work, aluminum 0.3, 2.4, 0.5, and 1.0% in the cobalt, chromium, ferrous, nickel, silicon, high entropy alloy was prepared by laser cladding. The microstructure, harshness, and high temperature erosion mechanism of the prepared aluminum, cobalt, chromium, ferrous, nickel, silicon, high entropy alloy was investigated systematically. The effects of the high quantity of the erosion particles, impact angle, erosion temperature on the erosion rate were analyzed. This research will provide theoretical support and experimental evidence for the development of high-end temperature erosion resistant protective materials, which are of great significance in promoting the application of high entropy alloy in engineering.